Hello friends, this lesson is all about questions on second law of thermodynamics. I have explained you all the concepts of second law of thermodynamics. This is a kind of mock test for you all. Just go through the concepts and after that try to solve these numerical problems. These problems are very important and it would be really helpful for you all to it would be really helpful for you all in gate and IES examination. So just try to attempt those questions on your own. After that, at the last slide you will be getting the answer key for all the questions. So here comes the question number 1. The question says, which one of the following statement is applicable to a perfect gas will also be true for an irreversible process? See, in the upcoming lessons of entropy, I'll be explaining you all the equations. The first equation is valid only for a reversible process. See, in the first law of thermodynamic equation, we have derived dq is equal to du plus dw. When dq is equal to du plus dw, it is valid both for reversible as well as irreversible process. The moment in place of dw you apply pdv, dq is equal to du plus pdv, it would be applicable only for a reversible process, The second is dq is equal to tds, it is also valid for a reversible process. Now the third one, tds is equal to du plus pdv. All these terms are properties. For example, temperature is a property, it does not depend on the path. Entropy is a property, it does not depend on the path. Internal energy is a property, it does not depend on the path. Pressure is a property, it does not depend on path. Volume is a property, it does not depend on path. TDS is equal to du plus pdv. These all are the properties. Hence, it is valid for a reversible as well as irreversible process because it is not a path function. In the first equation, dq is a path function, it is also a path function, but this it is valid for both reversible as well as irreversible process. So from first law, dq is equal to du plus pdv, dq is equal to du plus pdv. In place of dq we will write tds, so tds is equal to du plus pdv. I'll be explaining this equation in detail in the entropy chapter, in the entropy lesson, but for the time being, just try to understand this. So the answer is C. Question number second. A heat engine receives 1000 kilowatt of heat at a constant temperature of 285 degrees Celsius and rejects 490 kilowatt of heat at 5 degrees Celsius. Consider the following thermodynamic cycle in this regard: Carnot cycle, reversible cycle, irreversible cycle. ठीक है, विच वन ऑफ द साइकिल कुड पॉसिबली बी? मतलब आपको हीट दिया है 100 किलोवाट हीट 285 डिग्री सेल्सियस पे और रिजेक्ट हो रहा है 492 किलोवाट एट 5 डिग्री सेल्सियस पे. तो आपसे ये पूछा है, इट हैज बीन आस्क्ड कि वेदर दिस साइकिल इज कार्नोट साइकिल, रिवर्सिबल साइकिल और इरिवर्सिबल साइकिल. फॉर एग्जांपल, ये कैसे पता चलेगा? सबसे पहले हम एफिशिएंसी ऑफ कार्नोट साइकिल निकालेंगे विद रिस्पेक्ट टू टेम्परेचर 1 माइनस T2 बाई T1, बिकॉज कार्नोट साइकिल से ज़्यादा एफिशिएंसी किसी की भी नहीं होगी. नो एफिशिएंसी इज हायर देन दी कार्नोट साइकिल. सो फर्स्ट ऑफ ऑल वी विल कैलकुलेट द एफिशिएंसी विद द हेल्प ऑफ टेम्परेचर्स. After that we will calculate the efficiency with the help of heat. Then we will see which efficiency is higher or lesser. Let me tell you. First of all, we have calculated the Carnot efficiency, which is 1 minus T2 by T1. T2 temperature is 278 because here it is 5 degrees Celsius. So T2 temperature is 278 and T1 temperature is 285. So in Kelvin it is 558. So the efficiency of Carnot cycle is 50.179%. Now to calculate the efficiency of engine, we will take the heat, which is Q1 minus Q2 upon Q1. So efficiency of engine is 50.8. See, Carnot efficiency is 50.17 and engine efficiency is 50.8. And as I have already explained you, Carnot cycle is the most efficient cycle. No cycle is having higher efficiency than the Carnot cycle. So this is not possible because the efficiency of any cycle cannot be more than the efficiency of Carnot cycle. So the answer for this is D, none of the above. Question number third. A reversible heat engine receives 6 kilojoule of heat. 6 kilojoule of heat from thermal reservoir at 800 Kelvin. 8 kilojoule of heat from another thermal reservoir at 600 Kelvin. If it rejects heat to a third reservoir at 100 Kelvin, then the thermal efficiency of engine is equal to. See, if you remember the Clausius inequality, cyclic integral of dq by t is equal to 0 for reversible heat engine. In this question, it is mentioned the heat engine is what? reversible. In this question it is mentioned the heat engine is what? Reversible. So in this particular question heat engine is reversible, so heat input Q1 by T1. T1 is 800, heat is inputting 6 kilojoule. T2 is 600, heat is inputting 8 kilojoule, and Q3 heat is rejecting to temperature 100. So Q1 upon T1 plus Q2 upon T2 minus Q3 upon T3 is equal to 0, because for reversible cyclic integral of dq by t is equal to 0. So Q1 is what? 6 upon 800, Q2 is 8 upon 600 minus Q3 upon 100. So Q3 is equal to 2 kilojoule. Heat rejected is equal to 2 kilojoule with the help of cyclic integral. And what we have to find finally? We have to find the efficiency. So efficiency is net heat supplied divided by total heat supplied. So net is Q1 heat supplied, Q2 heat supplied, Q3 heat rejected. So Q1 plus Q2 minus Q3 upon total heat supplied, which is Q1 by Q2. So Q1 is 6, Q2 is 8, Q3 is 2. So 6 plus 8 minus 2 upon total heat supplied, which is 6 plus 8. So 12 by 14 into 100. So answer is 85%. Just keep this numerical in your mind. This has been solved with the help of cyclic integral Q1 by T1 plus Q2 by T2 minus Q3 by T3. So efficiency is equal to 85%. Question number 4. Consider the following statements. Zeroth law of thermodynamics is related to temperature. Is it true or false? Yes. Is it true? Entropy is related to first law of thermodynamics. No, it's not true. Entropy is related to second law of thermodynamics. Internal energy of an ideal gas is a function of temperature and pressure. No, it is wrong. Internal energy is all for an ideal gas is always a function of only temperature and temperature. Van der Waals equation is related to an ideal gas. No, it is not related to an ideal gas. It is related to real gas. So which of these statements are correct? Option 1. Only option 1 is correct. Zeroth law of thermodynamics is related to temperature. Only option 1 is correct. Fifth, for a heat engine operating on the Carnot cycle, the work output is 1/4 of the heat transferred to the sink. The work output is equal to 1/4 of the heat transferred to the sink. The efficiency of engine is, see, work output is given as 1 by 4th of QR. So heat addition minus heat rejection is equal to 1 by 4th of QR, because net work output we can write heat addition minus heat rejection. So heat rejection is 1 by 4 plus 1 upon heat rejection. So heat addition is 5 by 4 of heat rejection. So efficiency is 1 minus heat rejection upon heat supplied. 1 minus heat rejection upon heat supplied is equal to 4 by 5, which is equal to what? 20%. Right. So the answer for this is 20%. A. Question number 6. The question says, in a heat engine operating in a cycle between a source temperature of 606 degrees Celsius converted into Kelvin, 606 plus 273 source temperature, and sink temperature is 20 degrees Celsius, that is 273 plus 20, which is 293 Kelvin. What will be the least rate of heat rejection per kilowatt net output? W is equal to 1 kilowatt. We have to find the heat rejection. Source temperature is given, sink temperature is given. We have to calculate the heat rejection per kilowatt. W is 1 kilowatt net output of the heat engine. So this is the heat engine. T1 is in Kelvin 879, T2 is 293. Efficiency is 1 minus T2 by T1, which is 1 minus 293 upon 879. So efficiency comes out to be 0.666. Efficiency is work done upon heat supplied. W, the value of W is 1 per kilowatt net output. The value of W is 1. So Q1 is 1.5 kilowatt. So W is equal to Q1 minus Q2. Q2 is 1.5 minus W, which is 0.5 kilowatt. The value of Q2 is equal to 0.5 kilowatt. Again, I am telling you, T1 temperature is given, T2 temperature is given. With the help of these two temperature, we can calculate the efficiency. Efficiency is equal to 0.6666. Efficiency is equal to net work done upon heat supplied. Net work done is equal to 1. Heat supplied is 1.5 kilowatt. We have to calculate the heat rejection. Heat rejection is heat supplied minus W. Heat supplied is 1.5 minus W, which is equal to 0.5 kilowatt. Seventh question. Which one of the following statement is correct on the basis of second law of thermodynamics? First, for any spontaneous process, the entropy of the universe increases. Yes, it is true. See, delta S is equal to Q reversible by T at constant temperature. No, it is not like that. If the temperature is changing, we can integrate it. If the temperature is changing, we can integrate it. Efficiency of the Stirling cycle is more than that of the Carnot cycle. No. Always remember the efficiency of Carnot cycle is maximum. Del E is equal to Q plus W. No, it is not correct. Del E is equal to Q minus W. So the answer for this question is A. Question number 8. An engine working on Carnot cycle rejects 40% of the absorbed heat from the source, while the sink temperature is maintained at 27 degrees Celsius. Then the source temperature is C. Carnot cycle efficiency is given as 40% of the working on Carnot rejects. QR is given as 40% of QS. Heat rejection is given at 40% of heat supplied. Sink temperature is maintained at 20 degrees Celsius. We have to find the source temperature. So this is the figure T1, Q1, W, Q2. Q2 is given at 300. So heat rejection Q2 is given as 0.4 times Q1. Temperature T2 is given as 300. Q2 is given as 0.4 times Q1. We can write this because 1 minus T2 upon Carnot efficiency, 1 minus T2 upon T1 is equal to 1 minus Q2 upon Q1. With the help of that, we can get Q1 by T1 is equal to Q2 by T1. In place of Q2, we can write 0.4 times Q1. Q1 and Q1 will get cancelled. So T1 is equal to 300 upon 0.4, which is T1 is equal to 750 Kelvin. T1 is equal to 477 degree Celsius. Please go through these numericals. These are very, very important. It would be really, really helpful for you. Don't forget to rate, review, recommend, and share this particular lesson. If you want more lessons, I'll be coming up. Please ask anything in the comment section, any doubts, questions, whatever you want to theoretical concepts. I'll be replying to that. Thanks a lot from my side. This is the answer key. You can cross verify that. You can check that. Thank you all. This is Harshit Agarwal.